Hello everyone, welcome to the February month OWASP Trichy chapter meetup. So I'm Pranav here, and we have Jashmit and Nitin from the core members of the OWASP Trichy chapter, and we also have our chief guest, Athis SN, who is an active security threat researcher. So he has the topic of weaponizing dynamic linked libraries for us today. Before getting started with the session, let me just quickly introduce the co-members of the OWASP Tirupati chapter and then the chief guest today. So myself, Pranav Muralidharan, working as the security engineer at Cyber PWN Technologies. I take care of DevSecOps, cloud security, and threat modeling here in my organization. And we have Jashwantar, who is working as security engineer at Zoho. He is a really good expert at red teaming and active threat hunting. And then we have Nitin, who is also a security engineer at Cyber PWN Technologies, taking care of web application pen testing and DevSecOps part. So this is with respect to the core members of the OWASP Tirupati chapter. With respect to the chief guest, we have Athis SN, who is the head of Chennai DEFCON DCG 9144, and he's a co-member of the B-Sides Chennai. And being an active security researcher with certified CRTP and CRTA, he's working as security engineer at Ace Fox Innovation, and his threat hunting skills are valuable for the cybersecurity community. So, welcome to the today's session, everyone, and thank you so much for our chief guest Athis for spending his valuable time and coming to the OWASP Tirupati February meetup to share his knowledge into dynamic link libraries. This session will obviously be recorded, and the YouTube channel for the OWASP Tirupati chapter will be posted in the chat box. So in case if any of your friends have missed the session, they can go through the recording. So that's it for everyone. I hope you enjoy the session. Over to you, Athis. Thank you.
Yeah, thank you, Pranav, and thank you, Team OWASP Trichy. Am I audible?
Yes, you are audible, Athis.
Thanks, and yeah, good evening, guys. So let's directly start the topic. Okay, so I'm going to present, on the topic of weaponizing dynamic link libraries. Okay, so we'll have a short introduction or kind of a who am I about myself, right? My name is Athis SN, also known as APT Panda 19, right? And I have like around 7+ years of experience in information security in both red teaming and malware research, right? And I'm the head of DEFCON Chennai, the DCG 9144 chapter. And my areas of interest and expertise in cybersecurity, ranges areas from red team, malware development, exploit development, reverse engineering, and malware analysis, right? And I already did some certifications like CRTP, CRTA, MCRT, right? And apart from this, I'm also kind of currently working as a security engineer in Ace Fox Innovations, right? So yeah. And this is what the agenda of today's talk. We'll have a look at what is DLLs, right? Then we'll have a look at the internals of DLLs. Then some of the common attacks, the phantom DLL hijacking attack, the DLL sideloading and proxying attacks, then the DLL injection, and also the sophisticated reflective DLL injection, right? So let's get started. So we'll start, as what said, with the introduction to DLLs part. So anybody over here already having some experience, like they, anyone know about DLLs, like what is dynamic link library about? Anyone? Okay, so a dynamic link library stands for DLLs, right? So it's actually a kind of a portable executable in Windows, right? It's actually a Windows-based file to be precise. Okay, and the core part of DLL is that it contains a lot of code within itself that can be used by other applications, right? So let's take an example that you are a developer, right? And if you want to implement any audio thing into your application and all, okay. So instead of writing the code from scratch, you can import that code from DLLs, right? So that's the core idea of a DLL, right? And the other core part of DLL, it actually contains a lot of APIs, right? So the people who already have some sort of experience with Windows, okay, they know that Windows mostly functions on the Windows APIs or the Windows application programming interface, right? Which is of course a core component for the DLLs and also for the Windows, right? Because at the low level, whatever you do will be done with the help of the APIs, right? The Windows APIs, right? And they are the core part which will be doing all the operations, under the hood, right? And if and as what I said, the DLL of course is a part of the portable executable format. Okay, generally Windows follows the portable executable format, and within that it has the normal .exe files, the DLL files .srv, etc. and etc. Right. So similarly, DLL is also a part of the portable executable, as what I said, and a DLL file, which it cannot execute, okay, independently, and most of the time a DLL will be kind of loaded into the the address space or into the memory of another application, right? So let's take an example of Notepad, okay. So let's say if you're creating a file, okay, that create file, okay, will actually call a Windows API something known as create file A, okay. So this create file A is actually from the kernel 32 DLL, I guess, or from the user 32 DLL, okay, and that DLL would be loaded into the the address space or into the memory of the Notepad, the Notepad process, okay, and by that the further execution actually happens. So that's what a short the short anatomy of DLL. And now having a look at the DLL internals. So the internal structure of a DLL, okay. So as what I said, a DLL actually follows the portable executable file format, okay. And as how a portable an exe file contains a lot of headers within itself, the DOS header, the NT headers, the section headers, right? Similarly, a DLL would also have the same set of components within itself too, right? And a DLL can be a file can be considered as DLL if this particular image file DLL flag is kind of marked as, right. This is actually present within the file header, okay, of the of the image NT headers, okay. And it also contains the sections like the .text, .data, .idata, etc. That is kind of kind of common to see or normal to see within a normal exe file, right? And apart from that, it also has the import tables and export tables, okay. We'll talk about this in the upcoming slides, okay. And I will just show you the internal structure, okay, kind of showcase you the internal structure of the DLL, okay. So just a second. So I guess it's visible. So let me open P pair. So this application is known as PE Buyer. Okay, you can actually use this tool to kind of dissect the portable executable headers, right? You can kind of deep dive into the portable executable headers. What are the components being present and all, right? So in our case, I'm going to load a PE, okay, a DLL here. This is going to be the kernel 32.dll, okay. So kernel 32.dll is kind of considered as to be the mother of all DLLs in Windows, okay, as it contains almost all of the crucial functions within itself, okay. So uh, as what I said, it has the DOS header, the DOS stub, the NT headers, right, the sections within itself, etc. and etc. right. And while talking about this, one second, yeah. So as you can see, this file is a DLL, okay. So as what I said, that within the file header, okay, we have the characteristics, and this define that whether this particular file is a DLL or not, okay. And and as what I said, this particular file is a DLL file, okay. And the other crucial part of a DLL, okay, is the imports and the exports, especially the exports part, okay. So what does the export part actually states here, okay. So export means that this particular DLL is exporting or kind of exposing a lot of APIs which can be called and used by the other normal applications, right? For example, a Notepad, and Microsoft Edge, etc. A browser, whatever it may be, right? They would be utilizing these API functions, okay. That's been exported by a DLL, okay. So in case of kernel 32.dll, we have a lot of APIs being present here. As you can see, each one of these APIs will have a lot of functionalities within itself, right? For example, we have the create file, I guess it should be, yeah, as you can see. So yeah, so as you can see, we have the create file A, which is generally used by Notepad, okay, to kind of create a file. And Beneath this, we have several layers. Okay, we have the NT-DLL. Okay, that's another part which we are not going to covering today. Okay, for this we are just going to be within the user land. Okay, so as you can see, create file, and similarly every APIs would be having a particular corresponding ordinal number. Okay, so what do you mean by ordinal? You can take this as kind of an roll number or kind of a SAR number for each of every the Windows API is present here. Okay, so for example, if create file A, it would be present over here. I mean, the corresponding ordinal would be E1. Okay, and it differs from Windows versions to versions. Okay, so if you are kind of developing a custom shell code or a position independent executive shell code and all, it's necessary to kind of load the ordinals, okay, accordingly. Okay, don't just blindly trust any sort of applications like this. Okay, and what's this? Yeah, so that's I guess about the kernel DLL. Now, the second. Sorry. Yeah. So as what I said, that the import and the export mechanisms. So generally, these are kind of a tables. Okay, the export table and the import table. And while talking about the import table are generally used by the portable executable, right? So for example, again, your notepad, which is an executable, an exe file, which imports, okay, the particular DLL and perform all the operations, right? And generally, a DLL actually focus more on the export part, while the exe file is kind of mostly focused on the import the import part. Okay, there are some chance that in some circumstances there are chances that a DLL can also import. Okay, and a portable executable can also export. That's kind of one of the rarest moments, I would say. Okay, and these are all kind of managed by the the import address table, and also we have the export address table, okay, which we just saw in the PE bear application, right? So now we'll have a look at a bit about the DLLs and the DLL search order. Okay, so generally, in Windows, I'm talking about in Windows. Okay, so this DLLs. Okay, so let's say if the notepad, the notepad.txt wants the user, the kernel.dll, okay, within itself. So how it is possible to load that? Okay, within the process. No, yeah. So let's say that I want to load the kernel.dll into my notepad process. Okay, so how notepad would be able to do that? At that place we have the Windows loader. Okay, the Windows loader is the one which takes care of all the things. Okay, so from relocations, from resolving addresses, etc., and etc., everything will be taken care by the the Windows loader. Okay, and even while talking about even while loading of DLLs, it is kind of handled by the Windows PE loaders, right? So this is what the usual structure, I would say, about how an executable will actually load its DLL, right? So there is a kind of a search order here. Okay, so first it will start with the the application directory. You can ignore this as for now, okay, as it's not that much important, but you can just start with the applications directory. Okay, the application directory is kind of the current directory where your exe is present. Okay, let's say if I'm downloading notepad++.exe, okay, where that notepad plus 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 exe is present. Okay, that binary, okay, that can be considered as the applications directory. Okay, then we have the system directory. Okay, if the DLL if the DLL, okay, let's say I have the notepad++.exe within the application directory. Okay, it will look for let's say the user, let's say the kernel.dll. Okay, so the kernel.dll is of course not present in the application directory. So what it will do, it will try to parse the other the DLL search, the other DLL directories, okay, or the other directories where the DLLs can be present, okay, as per Windows. So if it is not present in the applications directory, it will go to the system directory, which is of course the Windows system 32, right? And if the DLL is not present over there, it will move to the Windows system directory. If not, then the Windows directory, and finally the current directory. Okay, and if even like if the DLL is not present, it will kind of directly move towards the environmental variables. Okay, if the DLL kind of present in the path environmental variable or somewhat like that, it will kind of directly load the DLL via that manner. Okay, and yeah. So another concept to have a look at is linking, right? So linking is generally, a kind of a concept in programming, right? And also, the people who have some knowledge on exploit development and binary exploitation, they might have also gone through the terminology linking, right? So linking is like, as what I say, that a DLL kind of, yeah, let's take an example of the DLL itself. A DLL will have a lot of, APIs and code, right? So in order to link that with the application, or, by whatever means, okay, the linking process comes into the place, okay? And this is generally done by the compiler, okay, and by the binary itself, right? So I will talk about that. Linking can be, it can be categorized into three main types. We have the static linking. Okay, so static linking means that, let's say I have the, a particular, a header file. Okay, that header file or a DLL. Okay, let's take an example. That DLL file, instead of, linking that, what I will do, I will kind of, copy the entire code within the DLL. Okay, into the portable executable, or into the exe file, or into the binary, right? So this makes the file, the binary size more bigger. Okay, so the main advantage is that you don't need to rely on any sort of, external headers or DLLs, etc. Okay, you have all the code within itself, so your particular binary can run independently, okay, without have to rely on anything else, right? And then we have the dynamic linking, which is the more common one, and the most, the famous one, kind of, linking methodology that's been used by almost all of the applications and developers too. So the dynamic linking is a part, like, where the compiler will takes care of the linking. For example, if again any sort of header file, or any sort of, let's take, example of the header file itself. We have, in case of C, we have the stdio.h. Okay, so if you want to link that, we can use a dynamic linking, which will again, like, taken in care by your, comparison all. And the third part is the runtime linking. Okay, this runtime linking is kind of a technique that's been even used by adversaries and also, researchers. Okay, so, instead of linking a header file or a DLL, okay, the part here is, we will, at the runtime, okay, when our binary is running, okay, we will load that DLL using, some sort of specified, or some, specific Windows APIs, right? For example, we have the load library A in Windows, okay, an API which is generally used to load any sort of DLLs at the runtime. Okay, again, understand, this is not the case of static or dynamic linking. This is runtime, which means that when the binary is running, it will automatically link that into the, into the address space. Okay, so, I will just, showcase you one example here. Just a second. Just a second, guys. So let me just open my, VS Code here. Okay, so, okay, let's take an example of the DLL injector. Okay, okay, so, it should be present here. Just a second. Okay, I guess, not present here. The product this would have, one second. So as you can see, we have the load library, W. Okay, that is, like, we have some sort of annotations over, the A and W in Windows. That's another part. Okay, so while talking about the load library, it is kind of loading the lib.dll. Okay, we'll have a look at in the, the upcoming slide while covering, the DLL proxying attacks. Okay, so this load library, what it will do at the runtime, it will load the DLL, okay, into the address space, or no, into the memory of the target process, right? So that's the concept of, the runtime linking. Okay, and, this is like, again, a short example of how the Windows DLL search order works. Okay, and, it's actually, taken from the process monitor. Okay, so as you can see, I guess it should be visible now. Yeah. So first, as what I said, the Windows loader will actually, have a look at the directory from which the application loaded. Okay, So then it will go to the system directory. Okay, and if it is 32-bit, or if it's 16-bit, I'm sorry, and if it is not there, it will directly have a look at the system directory. Okay, if not, then in the Windows directory, then within the current directory, right? And if not present over there, it will just have a look at the environmental variables being present here, right? So again, a short example for that. Okay, and this is what the actual pseudocode, not a pseudocode, but a dummy, a DLL code usually looks like, right? So this is a C code, of course, where we are including a header file. Okay, and similar to how Windows, similar to how a C function would be having a main function. Okay, C language would be having a main function. Similarly, we have for a DLL, we have the DLL main. Okay, and it has like three parameters and a switch case. Okay, so the DLL main, as what I said, it's having the H module, which is kind of handled to a module. Okay, in Windows, everything can be a file, kind of a file, a DLL, etc., can be considered as a module. Okay, in terms of the Windows language. Okay, so in case of DLL, it can also be considered as a module. Okay, so that's a part. And the DW, the D word, UL, reason for call, it's actually a parameter which kind of which the DLL asks the Windows loader, then what's the reason to kind of calling this particular DLL. Okay, so that's the reason. And we have the LP result, which is like mostly for some other operations. And here is we have the switch case. Okay, so we have the DLL process attached. Okay, and generally, as what I said, that the Windows, the UL reason for call will actually ask the Windows loader, right? Like what's the reason, and that can be kind of categorized into four main reasons. Okay, one is the DLL process attached, which means that your DLL is actually kind of kind of loading into another running process, right? So if that's the case, then the DLL process attached. If the process in which your DLL is loaded, okay, and if a thread is created at that time, this particular case should be executed. And if the particular thread is kind of terminated, then at that time this particular DLL thread detach will be called. And then finally we have if the process get exited, then we have the DLL process detach, right? So that's the anatomy of a sample DLL file. Okay, so now we are actually into the attack parts. We have the Phantom DLL hijacking. Okay, so most of the people would be having a confusion between DLL search order hijacking and the Phantom DLL hijacking. Okay, so I will just clarify you that in a bit. Okay, first we'll have a look at the DLL hijacking. Okay, so DLL hijacking, the Phantom DLL hijacking, which is also known as the DLL hijacking too, right? In this case, what it happens, of course, an executable, especially in case of an any sort of enterprise application. Okay, again, let's take an example of OneDrive or Notepad plus etc. Okay, once they are built, once that particular software version or once the software is ready, they would be having a lot of DLLs, kind of merged with them, or kind of how I can say, kind of zipped with them, I would say. Okay, or clubbed with them. Okay, so yeah, let's take an example. If you download Notepad from the internet, okay, after extracting the files, or after setting up the execution, the installer and all, you would be able to see a lot of .dll files would be present along with the Notepad ++. Okay, this has actually been developed by the developers. Okay, for the sake of functionality for the Notepad ++ application, right? So now what happens here? There are there are some chances that there might be some DLLs might be missing, right? Some DLLs might be missing. For example, if I have OneDrive, okay, OneDrive.exe file, okay, and that file has a lot of DLL within itself, but it is missing something like one.dll. Okay, so at that time, there are chances that that particular DLL can be optional. Okay, at the same time, that particular DLL can also be necessary to run. Okay, but that depends upon the application's versions and all, right? But in this case, while talking about DLL hijacking, especially, okay, we can just search for what are the DLLs being missing out. Okay, let's say if the one.dll is missing, okay, we can just try to kind of create our own malicious DLL and load and just copy that DLL into the directory where the actual directory where the actual DLL is missing. Okay, and just try to run the application normally. And if the application runs normally, and if it kind of loads our malicious DLL, okay, at that time there are high chances that we can receive a shell, or we can just perform some malicious operations, right? So that's the reason there should be an absent DLL which you people need to test. Okay, of course it's an kind of and hit and run, not hit and run, but a trial and error method. Okay, for example, there would be multiple DLLs would be missing within an exe. Okay, but it is not it is not that you would be able to kind of a malicious DLL for almost all of the missing DLLs. No, that's not the case. That would be kind of a rare trial and error chance where you'd be able to kind of perform that malicious operations and all, right? So this is as what I said, the visualization here. Okay, so as you can see that we have a legitimate applications which loads this API.dll. Okay, so just for the sake of an example, I'm just saying the attacker deletes the API.dll. Okay, this is not actually the case in case of actual real life attacks and all. Okay, so here the attacker just replaces that API doll, the API.dll, with the malicious version that's been created by the attacker. Okay, and now what happens? The once a legitimate application runs, it will load the malicious API.dll within itself, and all the malicious operation then will be performed as defined by the attacker, right? So now we have a small demonstration, with Phantom DLL hijacking. Okay, so I just recorded the POC for this. Okay, I guess the screen is visible. Is the screen visible? Can anyone please confirm?
Yes, Athis.
Yeah, thanks. So actually, the reason that I'm actually record POCs is that I'm having some issues with my my VirtualBox network drivers. So that's the reason I just directly took a POC video so that I can explain to you people over here. Okay. So at the start, we have the process monitor being running here. Okay, and okay, so we have the process monitor. And then we have for the sake of demonstration, I'm using the Notepad++. The version is 8.5.4. Okay, the Notepad the Notepad++ 8.5.4 is actually vulnerable to a DLL hijacking attack. Okay, you can just go to their GitHub repository. You'd be able to see all the documentations over there. Okay, so if I run the application, it's kind of runs normally. Okay. And if you open the now,
Athis, video is not visible.
Is it not?
No, it's not visible.
Okay, yeah, just a second. I guess now it should be visible. Am I right?
Yeah, now it's visible.
Yeah, that's fine. So let me just start from here. Okay. So as what I said, that we have the Notepad++, which just runs normally here. Okay. And now we are going to use process monitor to kind of filter out some things. Okay. So we'll just click on the filter option. And generally, if you're hunting for DLL hijacking based vulnerabilities and all, there are three main filters which you people need to apply. Okay. And they are kind of necessary too, right? So the first one is we need to start with the process name. Okay, so the process name, okay, with our actual target application. So in our case, it's Notepad++ dot so just click on add. Okay, as you can see, it's added now. Now the second filter that we're going to have a look at is the result. Okay, that's what the result that we're looking for. Okay, as what I said, that we are looking for the missing DLLs. So the result should be something like name not found. Okay, which means that this particular DLL or DLL, this particular dependency is missing. Okay, so the result is the result contains and name as name not found. Okay, so just add that, and the second filter also is also done. Now the final filter, which is the path. Okay, so the path ends with .dll. Okay, so we are just searching for the missing DLLs. That's the part here. Okay, so just add it. And now just rerun the notepad plus plus. Okay, some issues. Okay. It's actually process name contains. It's a small mistake. Yeah. So as you can see, after running this, we'd be able to see a lot of DLLs being missing. Okay. For example, we have the program files. This is where the directory where the Notepad++ is installed. Okay. The program files Notepad++. This particular version .dll is missing. Similarly, we have a lot of DLL file being missing. Okay. Sense API.dll, right? We have the etc. and etc. So we are going to utilize this particular DLL, which stands for MSASN1.dll. Okay. And even if you go to the official documentation for the the DLL hijacking of the Notepad++ 8.5.4, they also kind of exploited this particular DLL, the missing of this particular DLL. Okay. And the MSASN1.dll. Okay. So now we are back into our Linux machine. I'm just going to create a normal malicious DLL. Okay. If in case if you want to use any sort of C2 server, of course you can also use that. Okay. But just for the sake of demonstration, I'm just using it. Okay. And again, it's not object safe to or kind of object friendly to use Metasploit, as you people know. Those who are into the blue team part, of course. So again, just for the sake of demonstration, I'm using Metasploit. Okay. So I'm just creating a malicious DLL with some configurations. Okay. And I'm just creating the DLL with the name of that missing DLL. As you can see, we have the MSASN1.dll. Okay. So now the DLL is created. Let's share that DLL. Okay. Okay. And yeah, once it's downloaded, so it's done. So now the actual part. Okay. So that DLL is now downloaded. So now what we are going to do here, we are going to copy this MSASN1.dll into the directory which we saw in the properties part, or in the process monitor. Okay. Which is in the C program files Notepad++ that MSASN1.dll. Okay. So we're just going to copy that. So as what I said is in the program files Notepad++. Okay. And so let's start a reverse shell here. Okay, I'm in a listeners here. Okay. And now let's go to our, I'm sorry. Now let's go to our victim machine once again and just try to execute this. Okay. So if I just run the application, okay, once again, and if we go and switch back to our, our Kali machine, we actually spawned a shell. Okay. So that's how easy it is to kind of exploit and DLL hijacking vulnerability. But again, as what I said, it's kind of an a trial and error method, right? So let's say you have 100 DLLs being present, but there are high chances that maybe one of the DLL, or if not almost none of the DLLs, would be able to kind of exploit this and all, right? And if you people just a second, yeah, it's working. And if you people notice here something, that we actually got an error here. Okay, it's not an error, that the application should actually work or no, it should be work normally. Okay, let's kind of the usual flow. That's no usual flow. Okay, as the DLL is hijacked, it kind of cross the application to crash. Okay, even though we got a shell, the application is not properly working. Okay, so this particular thing, it can be kind of kind of an easy detection, I would say. And the other part is to kind of thwart this or to kind of fix this, we have the DLL proxying attack. Of course, we'll have a look at that in the upcoming slides. Okay, so that's the phantom DLL hijacking, I would say. And just a second. Yeah, so that's the part for this. And some of the the DLL hijacking prevention is that you can remove any sort of unnecessary or outdated DLL references from applications, right? And yeah, now coming to the part of the DLL search order hijacking, right? So uh, study chance. Okay. Okay. So in case of DLL search order hijacking, many of the most of the people they used to confuse between these both. Okay. So DLL search order hijacking is like somewhat putting your malicious DLL before the the actual the search order, or before the actual parser, I would say. To be precise, let's say that you are looking for the directory from which the application will. Okay, so that is a structure, right? We have this, like, that is a flow. The Windows loader will kind of goes through all of this. Okay, so now let's say that our particular DLL, let's say if the particular binary is kind of vulnerable to DLL search order hijacking. So what we will do, we'll put our malicious DLL in one of the directories which is above the the above the actual directory, right? So let's say if our process is actually executing from the current directory, okay. And what we will do, if there is a DLL search order hijacking vulnerability, we will put a malicious DLL in the Windows directory. Okay, so now what happens when the Windows loader, which which actually passes through the Windows DLL search order, it will directly load the DLL present within the Windows directory, which is a malicious one, instead of the actual one. Okay, instead of the actual one which is there in the current directory. Okay, so of course, this is also like one of the rarest cases. The DLL search order hijacking, all right. And if that's the case, our DLL from the Windows directory would be loaded into the target application. Again, the malicious things would be done, right? So that's the part of DLL search order hijacking. And while talking about phantom DLL hijacking, it's more often hijacking or exploiting a missing dependency or a DLL, right? And yeah, as you can see, we can have a look at the logs for any sort of repeated failed DLL load attempts, right? And the main part is like use fully qualified path when loading optional dependencies. This part is like really important. If you people have some experiences with exploiting unquoted service path vulnerabilities, you might be able to grasp like what I want to say. Okay, and the other main part is like just try to restrict kind of impose some restrictions, especially able, like, as an attacker or someone will be able to write any sort of DLL, right? So just impose some restrictions about writing to particular directories, right? So now the and another sophisticated attack technique which you are going to have a look at is the DLL side loading and DLL proxying. Okay, so DLL side loading is generally used by the nation state or also by the APT groups more commonly, right? The reason is really simple. It's stealth. Okay. What's the main point for DLL side loading here is that here you would be having the DLL next to your application, right? So for example, if you go to the previous example of Notepad++, where that is where like there were the MSES and one.dll is missing, right? So what if that particular DLL is missing? I mean that DLL is present, okay? And what we will do, we will actually just rename that DLL, that MSES and one to anything else, and we will create another another malicious DLL with the name of the MSAS1.dll, and just keep it within the same directory where the executable is present, right? So once the executable loads, of course, it will first look within its application directory, or within where the application is present, right? So it will directly have a look at within its application directory. So at that time, what happens? It will load our malicious DLL once again, right? I know it's kind of a bit confusing. We'll just talk about that, in few seconds, okay? And the main part of DLL side loading is like the abusing of digitally signed executables, right? So let's take an example of the the OneDrive, okay? I've seen a lot of adversaries or APT groups. They used to use OneDrive, as kind of to kind of exploit the DLL side loading stuffs, okay, to kind of perform the callback, the C2 callback stuffs and all, right? And why is digitally signed executable? Because they are more trusted, okay. And if an binary is kind of more trusted, of course there is some less shade over that, okay, or kind of a lesser shade over that. by any sort of defense mechanism being present into your system. It may be defender or EDR, etc., whatever it may be, right? So again, like this is what the DLL side loading attack flow here. Okay. So again, like we have the let's say we have a vulnerable application. Let's take an example of the OneDrive. Okay. So here we have we'll kind of place the DLL as what I said within the directory where the OneDrive executable is present. The actual DLL to something else, and again, like as what I said, that's a part here. Okay. And the DL proxying part, it's kind of fixes the error or fixes the problem of what we have encountered during the DL hijacking attack, right? So as we as at the last we saw that there was some issue after spawning a shell. The application, the Notepad plus plus isn't like normally functioning, right? It's not opening, right? The reason is because it is kind of loading a particular DLL, okay, and that DLL is missing some exports, okay, or which can be used by the DLL, which can be used by the Notepad plus plus E application, right? So what if we create the DLL, okay, a malicious DLL itself, okay? I'll do one thing, okay. Let's take an example for this, okay. So this is the usual flow, okay, where in middle, okay, in case of a DLL hijacking, we just had two main things. We had a program.txt or binary, then we have the malicious DLL, okay. So this particular malicious DLL would be directly loaded into the program.txt, right? But in case of a DLL proxying, we will do something like this, where we would be kind of no, so as you can see, we would be kind of placing our malicious DLL as a proxy between the actual application and the actual DLL, okay, or the legitimate DLL, right? So if you just notice here, we did something that we have the actual DLL name is legit.dll, okay, but we have changed the actual the original name to something like legit1.dll, okay. So this is the actual DLL, okay, and this is the malicious one. And what we have did, we have kind of changed the malicious DLL name to legit.dll, which is actually which is the one which is going to be loaded by the the application, right? So now the part here is, as what I said, like, and DLL would be exporting a lot of functions and also APIs, right? So that can be kind of used by the the main binary, right? So last time why it crashed, because there was some dependencies it was missing out, right? So now in case here, what we'll do, we'll create a malicious DLL, right? And we will create a forwarding here, okay, that kind of a forwarding here. So let's say for program.exe, just for the sake of demonstration, so for the sake of example, that if it is kind of looking for create file A, I'm just saying this for an example. So what we will do, we have the malicious code, okay, like we have the malicious DLL, and we will forward the request to the actual legitimate DLL, okay. And what it does now, it will of course execute the create file A, and also it will also execute a malicious DLL, right? So in this way, our application won't crash, okay. So that's the main or the core idea of the DLL proxying attack, right? So yeah. So now we have a small demonstration for DLL proxying. And before that, I will just showcase to you people about some of the code snippets which I have for both the DLL side loading and the DLL proxying, right? So just a second. Just a second. So we'll just have a look at okay, just have a look at the asm.sln, okay. So I have created this particular POC for the DLL side loading attack, okay. So as you can see that in case of here, at the time of demonstration, I just showcase you that what is what is that particular a target binary is actually in need of, okay. So okay, I'll just first walk through you people with the code, okay. So we are actually creating some exports here. Okay, some DL exports. We primarily have four functions, which is the curl no curl easy init, curl easy set opt, curl easy cleanup, and curl easy perform. Right. So these four functions are kind of required by the Notepad++ exes gub.exe. Okay, I'll talk about what is gub.exe. Okay, while the time of demonstration. Okay, and for the sake of POC, what I've created a simple message box. Okay, which will kind of after the successful exploitation of a DLL side loading, we will have a message something known as DLL side loaded. Okay, and with kind of a message box. Okay, and yeah, that's more often what's the part here. Okay, it's a very small code snippet. Okay, so just for the sake of demonstration. Okay, and now let's yeah, okay. I'll just open the another project too. Okay. Just a second. Source and yeah. So this one is for the DLL proxying attack. Okay. So we'll just go through this. Okay, after at the time of demonstration. Okay. So now what the code does is, again, like we're exporting the curl easy init. Okay, because this is the the first function that's going to be called by a target application, right? And as we have this being forwarded to our actual legitimate DLL. Okay. So and after this we have a shell code. Okay, normal shell code, and then we are allocating some memory. Okay, within the within the target process. Okay, and then we are creating the thread to execute our shell code, right? And as you can see that at the runtime we are loading our lib.dll. Okay, so for the sake of demonstration I'm going to use something known as a gup.exe. Okay, which is something related to the updates for the Notepad++ application, right? So let's say if you want to look for any sort of updates for the the Notepad++. Okay, you can use the gup.exe. Okay, so we are going to abuse that. Okay, and again, like we are just exporting some dummy exports being present here. Okay, and again, like we have the DLL code, the actual DLL code being present here. Okay, just for the just for some small implementation. Okay, so so the core idea over here is like we would be of course attaining a reversal. Okay, once again, right? And we are loading the lib.dll. Okay, which is the actual name is lib called libcurl.dll. Okay, and we are going to change this as lib.dll. Like we are going to rename this as. Okay, and we are going to create this. Okay, this particular DLL as the libcurl.dll, which is the malicious one. This malicious one is going to be renamed as libcurl.dll. Okay, and by that all the operations will be performed. We will be forwarding all the calls, and these are the functions that's been kind of exported by the actual libcurl.dll. Okay, and we have implemented that here. I will just walk through you people that how you would be able to implement this also within your target within your malicious binary itself, right? And now what we'll do, as you can see, it will be kind of forwarding all the all the exports or all the function call to the original libcurl part, right? And along with this we also have the ordinals present being here. Okay, and it is really important for you to also add the ordinals. Okay, so yeah, now we'll have a look at the demonstration. Just a second. And okay, so I have two demonstrations here. One is for DLL side loading and one is for DLL proxying. Okay, so first start off with the DLL side loading. Okay, so yeah, should be visible. Yeah, yeah, now it's fine. Okay, so again, like now we are in again like another small POC here. Okay, so now at the start I have loaded the P bear. Okay, and within this, as what I said, our target our target DLL for the gub.exe. Okay, as what I said, the gub.exe is the one which actually looks for all the updates. Okay, like if you run the gub.exe binary, you would be able to see the updates that's kind of present for the current Notepad++ application, right? So like that's kind of present within your system, right? So now I have loaded the gub.exe, right, within the paybear, and it has it requires a libcurl.dll, and that libcurl.dll has four functions. As we just saw, we have the curl easy, right, setup curl easy, etc., and etc., right, as you can see. So these particular four functions are kind of in need for us, okay, to kind of make the workings properly, okay, so that our application won't crash. Okay. So now again, like as what I say, that we are just implementing those exports, okay, within our within our actual malicious DLL itself. Okay. So as you can see, we have implemented the curl easy cleanup, the curl easy perform, and all, right? And so now the core part is, do you have the actual libcurl.dll being present here? So what I'm going to do here is, we are just going to rename this, okay, to lib.dll. Okay, we're just changing it to lib.dll. Okay, and now we are just running this. Okay, and after running the gub.exe, as you can see, it requires the binary libcurl.dll, okay, which was not found. As the reason, as what I said, that we have changed our we have renamed our DLL, right, to from libcurl to lib.dll, so we got an error. So now so I have an DLL, something known as the ASN DLL, which is of course my malicious DLL. So I'm just going to rename the ASN.dll to the libcurl.dll. Okay, so just renaming that. Okay, and after clicking on continue, and if I run gub.exe, okay, as you can see that I got DLL side loaded. Okay, and yeah, so that's the part of the DLL side loading. Okay, and the core concept, as well as want to say here, that we have the gub.exe, and within this directory itself we have the libcurl.dll, this particular DLL. Okay, so we are abusing this, as there's no search order being present here and all. Okay, as we have the target binary here, and along with that we also have the DLLs here. Okay, and in case of the DLL hijacking and all, there are high chances that your DLL might be somewhere present else in any other directory, right? So exploiting that can be kind of more complicated, right? Not kind of complication, but the chances of hitting the exploit, it's really tough, I would say. But of course, DLL sideloading is more often used by attackers, as it is really still there, right? And most of the time, the attackers are actually focused on signed binaries, right? It may be OneDrive or it may be any other binary, okay, which has been signed by Microsoft, especially, right? As what I said, right? So that's the part of the DLL sideloading. Okay, again, I'm saying the DLL sideloading means we have the application and also the the malicious DLL present within the same directory. Okay, so that the application will directly load it within its process place. Okay, without triggering any sort of alerts, I would say, most probably. So now we'll have a look at the DLL proxying. Just a second. Just a second, guys. So loading. So now we have the part for the DLL proxying, right? So again, like as what I said, we are going to input all of these export functions to our target DLL, right? So before that, first we need to create a shell code. Okay. So again, like I'm going to use MSF Venom from here. Okay. You can just use any. You can even like use any other your custom shell code loaders if possible, right? Again, it's not object safely. Okay. So I'm just creating the shell code, just a normal C-based shell code. Okay, and okay, And as you can see that I have renamed our target, and in the actual DLL, the libcurl DLL to the lib.dll, as you have saw and as you have seen in that course snippet itself, right? And as you can see, we have the libcurl.dll being present. This is our actual DLL, okay, which is our malicious one. So now it's time for us to kind of have a look at the exports, right? So how to kind of export the export all of these things and all of these functions, okay? So after opening pbear and after opening the actual lib.dll, which is of course the libcurl.dll, I just renamed it. And if you just have a look at its exports, okay, the DLL export, the exports, it would be having around like more than 70 to 80 export functions being present within itself, as you can see, right? So now what we are going to do here, we are going to export all of this, okay, to our malicious DLL, okay. So for that, I have a PowerShell script, okay. Of course, that's been downloaded from the internet. I will just share the link, okay, attached with the slides, okay, after the session gets over. So just first, I'm importing that particular PS script. Then I'm using the DLL. I'm using the DLL path argument, and just specifying. So yeah, I'm just specifying the particular target DLL. Okay. Again, see, people don't get confused that we have two DLLs. One is libcurl, which is my the actual name is libcurl.dll. Okay, which I've changed it to lib.dll, and the malicious one as libcurl.dll. Okay, so just make that note of it. Then I'm going to export, okay, that to this particular directory, the downloads itself, okay, with the output as exports.txt. So as you can see, after running the script, we got a lot of we almost got all of the DLLs, okay. I'm sorry, like almost all of the functions. And if you just have a look at that particular file, okay, the output file, we'll be able to see all the particular functions being present, right? And those functions are kind of directly imported to my malicious DLL, right? So as what I say that we have the export, right? We are exporting this, and if if the application calls curl easy cleanup, okay, this will be forwarded to our to our actual lib.dll, okay, and with that we our malicious shell code will also be kind of executed parallelly. Our the normal functionalities would also be kind of going along the way. So this time it won't get crashed. That's a part. Okay. And let's start netcat listener here. And let's just run the application. And I guess I got an error this time, not kind of an error. Literally, I crashed my application, I guess. Yeah. So as you can see, I actually got a reverse shell, but the problem is that I literally, kind of messed up with the gup.exe. Okay. The reason is kind of, I was kind of experimenting with a lot of time, kind of, changing the flows and all. So that's the reason it kind of, crashed here. But in, previous attempts were kind of successful. So just kind of due to the crash of application, I almost got in shell, but yeah, failed due to some messed up things. Okay. So that's how the part of DLL proxying. Okay. So in case of a normal flow or a usual flow, okay, in case of with DLL proxying, the application would normally run and you will receive a shell. Okay, so that's the part of the DLL proxying it. Okay, and of course DLL proxying is also most healthier as compared to the DLL hijacking attacks, right? As we are kind of actually kind of forwarding the actual functionalities, okay, to our legitimate DLL. So that's one of the case. So again, like DLL side loading and proxying preventions. Okay, so make sure you kind of enforce the proper DLL, the digital signatures. Okay, before loading any sort of DLL, right? And use any if possible, use load library X, which kind of comes up with some safe flags which you can configure at the time of loading any library. So that's one part. Okay, and if possible, implement application whitelisting. Of course, you have app lockers and all, and also WDAC. Okay, and of course, you can also have a look at this is the last point. It's like in case of the in case of, I would say, DLL hijacking, where if your DLL is actually loading from any non-standard directories, right? So that's a part. So now we are into the DLL injection part. Okay, this is an infamous kind of not kind of a kind of an process injection technique, I would say. Okay, so DLL injection is kind of a technique where we would kind of force an application, okay, to kind of load our malicious DLL within itself. Right, this is somewhat similar to the DLL hijacking, but here we are not going to exploit any missing DLLs. Okay, instead of that, we are just forcing an application. Let's take an example, or forcing a process. Let's take an example of Notepad. If the Notepad instance is running, we'd actually force Notepad to load the DLL within itself, right, and thereby performing all the operations, right. Uh, is it visible? Yeah. So, and the main part over is that the DLL, the injected DLL runs with the same privileges as the target process. So let's say if your target process is a high, kind of having with high privilege, okay, running with a high privilege, and if you're loading a DLL within itself, then of course it's a high chance that you can also execute your privileges easily, right? So yeah, that's the one thing. And of course, DLL injection is like kind of of course one of the widely used technique by red teamers and APT groups, etc., etc. Right? Of course, the people who even have some basic knowledge on maldev, they used to know about what is DLL injection, right? So the injection mechanism, okay, how it works. So the attacker, he basically first obtains and handle to the target process, right? So let's say if I want to inject an DLL into the target process, let's say Notepad, I first need to obtain and handle, right? So by that, after kind of after after obtaining and handle, right, we need to allocate memory within it, okay, so that we can load our DLL within that. Okay, then the DLL path, okay, is written into remote process. Okay, there are like a few instances, right? Either you can load the, you can actually include the DLL path, okay, within the binary itself, or at the same time you can also give the DLL path as an argument. Okay, that depends upon your implementation of the malicious binary. That's another thing. Okay, so the DLL path, of course, which will be kind of written into the remote process using the right process memory, Windows API, right? And finally, our kind of all the shellcode part would be executed with the with the create remote thread API, right? So yeah, that's the part. And as you can see here, also we have a flow here. So we have the get process handle, then we have the virtual alloc X, okay, generally used here to kind of allocate some memory. Okay, then we are actually writing the DLL path. Okay, and with that, our particular malicious DLL would also be loaded using the load library. Okay, and yeah, that's a part. That's more of it. So we have the demo here, and before that, again, like I just want to showcase you a a small code snippet here. Okay, so just a second, guys. Okay, just a second. Just open project solution. Just a second. So I have created something like the yeah, DLL injector. Okay. Okay. So this is what the implementation for the DLL hijacking. Okay. So at the very first, okay, at the very first, we are actually taking our process PID as an argument. Okay, here, as you can see, we will be specifying our target process. Let's say if Notepad is having an process ID of 5555, we will be providing that at the time of execution, right? Then this is our pound, or this is our malicious DLL. Okay, this would be actually loaded into our target process. Okay, so we are actually directly hard coding. Of course, this is not OPSEC safely, I would say. It's not OPSEC safe, as we are like directly mentioning the DLL name. Okay, and then we are just loading that. Okay, we're just specifying the size and all. Then this is the main part that we are actually obtaining a handle to the target process. Okay, So we are using the Open Process API from Windows. Okay, and with this we are going to open and handle to the Notepad plus the Notepad or any other target application, right? And then after that, as what I said, we are using the virtual alloc X. Okay, and again, some people is to get confused here with the virtual alloc and virtual alloc X. Okay, so virtual alloc is to kind of allocating memory, additional memory, or no, let's take an let's even say like memory within your current process. Okay, and if you want to allocate memory within your target process, at that time you are into a remote process. At that time, you need to use the EX, which stands for I guess it's external version. Okay. So here we are just passing some arguments. For example, our handle, right? Then some page mechanisms and also protections. So we are just giving us page execute read write so that we can directly inject this. And also page execute read write. This is of course a red flag for any sort of EDR or maybe even for Windows Defender. So make sure you use virtual protect API to kind of change this accordingly. Okay. Then we have the write process memory where we are actually writing the DLL path into the target process. Okay, and then we are actually loading the kernel.dll. Okay, and from that we are using we're actually loading the load library A, right? And this, as what I said, that the load library is actually responsible for loading DLLs at the runtime. Okay. Then we have at the end we have the create remote thread, which is going to create or which is going to execute, like it is going to create a thread which would be executing our shell code, right? Or yeah, in our case RDL, right? So that's a part there. Okay. So now let's go to the demonstration part here. Okay. So just a second. Just a second, guys. Okay. So the usual flow starts something like this: that I have the DLL injector. My malicious binary is being present here, as you can see. Okay, and as usual, the first part is again like we are going to generate a shell code using MSF Venom. Okay. Again, like we are creating a malicious DLL here, which is named as pound.dll. Okay. And we are just transferring this pound.dll to our target machine, right? And again, we have already specified the hardcode path where the DLL would be stored. Okay, so you need to just place the DLL over there, and the DLL should be there, or like it should be present, or else there's a high chance that it can get crashed, right? That's a part. So we are just downloading that. Okay, pound.dll. And now we'll just start a netcat listener here. Okay. And as you can see that pound.dll present. And as per, even if you have a look at a code snippet, as what I said, it is present in the users Athis, and then you have the pound.dll direct, within this directory, right? Our pound.dll is being present. So that's great. So now we are going to have an open task manager. Okay. So within the task manager, if you go to the details tab, you'll be able to see the process, the PID of all the processes being present. Okay. So here, okay. Now the next part is we are going to open Notepad plus the usual Notepad. Of course, another a red flag here that please load any don't load any sort of malicious thing into the Notepad because it is unusual. Okay, and it can be easily detected by even a basic Windows Defender or also by the EDRs, right? So just make sure of that. Okay. So we have opened a Notepad here, and okay. And after this, we'll to see that our notepad.exe is PID is 8044. Okay. So now I'm just moving into the DLL injector where my malicious binary being present. Okay. And now, as what I said, that we are going to specify the target process, the PID as an argument to the DLL injector, right? So it's 8044. Okay. And after running this, as you can see that we got the location and all, like everything is success. We are allocating memory at the target process, writing the DLL path, Then we're also kind of where we are loading the kernel thread to DLL and its address, then some other stuffs, right? And finally creating thread at the target process, which means like almost done, no errors. And if you go back to our attacker machine, okay, uh, as you can see, we spawn a shell here. Okay, so that's what how easy it is to kind of implement a DLL injection attack. And of course, DLL injection attacks in the modern day can be easily detected, right? So make sure, and of course, if you're using hard-coded DLL paths and also some basic shell code, of course, it can be detected. And apart from that, many other things being present, right? So just take that into consideration, right? So that's the part for that. And so now we're into the prevention part. Okay, so and as you can see that enable proper process protection, okay, mechanisms, so that you kind of restrict some applications, kind of some crucial applications to kind of how I can say, kind of thwarting them, kind of thwarting the the arbitrary DLLs to be loaded. That's one part, right? And make sure of the memory permissions and protections. That's one thing, right? And I would say that in to kind of detect an simple DLL injection, a very basic EDR is fine, right? So that's a part. So the final part is the reflected DLL injection. This is a more advanced version or an advanced variation of DLL injections, right? So here what happens, okay, so here the actual part here, okay, so that as we saw in the previous example, that we have the the pound.dll or our malicious DLL is actually loaded into the disk, right? It's actually present in the into the disk. And even in the code in the code snippet, we had the hard-coded part of our part to the malicious DLL, right? So the reflected DLL, what it does, this technique, it will actually download, or it will load the DLL completely into memory, okay, completely into memory, without touching the disk, right? This will, of course, bypass, your Defender application or any other, static signatures, etc., right? And your basic antivirus scanners, because antivirus scanners generally they used to look for, the files being present here, okay, or whatever files being present in the disk, right? They will scan for that, right? But in case of reflective DLL, no, in case of reflective part and all, you will be directly loading that into the memory. Okay, like you're like literally loading the entire DLL. And talking about the entire DLL, you're just this part is a bit complex, because you would be loading the DLL, but step by step. Okay, like you will be parsing all the portable the headers, as you can see, as what I said, right? DLL would be having multiple header within itself. For example, the DOS header, then it be having the the optional headers, etc., right? Then sections, right? And we also have the relocations which we need to fix up and all, right? So all the things would be taken care by our this reflective DLL injector, right? Which will directly kind of a custom reflective loader, custom reflective loader, right? So this is somewhat similar to how a Windows loader is. Okay, so a Windows loader kind of loads the DLL into the into your application or into your binary. In the similar way, our reflector, this particular custom reflective loader will also work, right? So as you can see that as what I say that the internal workings, that the reflective leader, the reflective loader manually allocates memory and maps the DLL sections, resolve the imports, and applies relocations before parts, right? And now what is relocation? Some people might be asking me. Okay. Just a second, yeah. So relocations, generally what happens, okay, once you compile your any executable, right? Let's say let's say what we can say, okay, let's say notepad.exe, okay, stay playing this for an example. Okay, let's say we have notepad.exe. Okay, so at the time of compilation, okay, the we have something called as the base address, okay, which will be kind of in present in the portable the process environment block, or the PEB, of the target process. Okay, and it has the image base, okay, where this image base contains the address, okay, where your the address range where your executable would be loaded after running, right? So as you can see in modern day applications, in modern day scenario, we'd be having a lot of applications being running simultaneously, right? And also due to some protections like ASLR, address space layout randomization things and all, there are high chances that these memory addresses can actually fluctuate and all, right? So to kind of fix that, okay, and to kind of align with the predefined the image based addresses, we can we have the dot relog section, of course, dot relog, which would be present almost in all of the modern day the portable executable files, okay. And after running that, this real headers, no, sorry, the real sorry, the dot relog section would be having the memory addresses, okay, on where the particular the patches need to be fixed, right? And like it kind of contains the memory addresses which need to be fixed properly, right? So that would be like really good to kind of get aligned with the the preferred image base and kind of offering a smooth execution and all, right? So that's a part. So why reflective again? So again, as what I said, that the the DL the DL never touches the disk, right? And kind of it avoids the standard DL the standard Windows loader, okay. And this of course makes really useful for adversaries, especially in post exploitation stuffs and all, right? And of course it can also bypass traditional file based monitoring solutions and all, right? So now, okay, we are into the the reflective DLL injection demo. And again, before that, we have this the code snippet over there. Okay, I'll just showcase the code snippet. Okay, just a second. So I have already wrote a loader here for this. It should be somewhere. Yeah, this one reflective DLL injection. Okay, just load it over here. Okay. So this is what it usually looks like. Okay, I will just recommend you people that before going on to reflective DLL injection and all, like especially while going through the loader, it's better that if you already have some understanding about PE parsing or portable executable parsing, right? So if you have some experience with that, of course you can easily read out the code over here. Okay, or else it would be a bit tough, but still I will just try my best out to explain the things, right? So first, we are just defining a function, something known as a download from URL. Okay, so which is in our case, what I'm doing here, I'm actually hosting my hosting my pound.dll, okay, in my Kali machine or an attacker machine. Okay, and after after running our malicious our reflected DLL loader, it will directly download the pound.dll from there, and it will construct the entire DLL format and all everything within the within the memory of the target process, right? So that's a part there. Okay, so this download from URL function, it kind of first opens, it's kind of initializing the basic internal functionalities, and we are using the win-inet.lib direct library here. Okay, and then we are making some connections over here. Okay, using some Windows APIs, as you can see. And we are just defining some some capability some capacities and for buffers, right? Generally for storing our pound.dll. Okay, that's part. And this particular part is about reading the file. Okay, it will kind of read the file that's been present from our attacker machine where the pound.dll is hosted, and it will directly load that into it will read the entire file. Okay, and for that we are also implemented some stuff here. We are actually allocating that based upon the size of the pound.dll, as you can see, right? And I have limited a size of around 16 kbs here. Okay, and even like if it is more, there is some sort of adjustment being going on here. Okay, and some stuffs. Then after this, we are just closing the handles to it. Then here is the main part that we have the URL here, which is where a pound.dll is present. Okay, of course, again, it is hard coded. It is not recommended in terms of OPSEC. Okay, and then just we are actually calling the download URL from URL function, and we are just passing some arguments, the size, and also the download URL. Okay, this particular URL. Okay, and now we are passing the portable executable header. Right, this is where the things actually gets interesting and a bit complex. Okay, we are just creating some a structure here. Okay, DOS, and we are just verifying that whether it is a valid PE file or not, right? Then of course some signature checking being happened here, right? And then we are getting the size of image, okay, which is the size of the DLL, okay, we're just getting that, and we're just allocating based upon that. And again, as you can see that we're just keeping this as page execute read write. Of course, it is not recommended. Um, then some again like some other operations focused on memory allocation. Then we have I guess it's the copying. Yeah, so this part is about copying the sections. As you can see, we have the dot text dot you know like a portable executable. Of course, it will be having a lot of sections, right? So that sections would be copied, okay, within or kind of it would be organized and it would be copied, okay, from the actual pound.dll, okay, and that's the part here. Then here we will be focused on the relocation part. As what I said, it's kind of imposing you know some relocations and fixing that the predefined image based stuffs and all, right? Of course, this code might have looking complex, and as what I said, if you have some experience in passing portable executable headers, it would be really easy for you to kind of understand the code. And then we are traversing through the we're traversing through the the sections, okay. We're just implementing chunks and all, okay. And yeah, it's more often again like we'll be passing all the exports and the ordinals, right, etc, etc, right? And then at the end we will be just focusing on loading our DLL, okay, into the target, into the address space, right? So here we are not going to use any remote target. We are just going to load the DLL within our own process itself, right? So you can just ignore these parts, especially the allocation, the reload part, okay, the relocation part, okay. Like just for the understanding the code I'm saying, okay. The rest of all the parts are kind of important, okay. So that's the part of the the code snippet. Now we'll actually just a second. So yeah, as you can see, this is a very small demonstration here, okay. So again, like as you can see, we have the pound.dll being present here, okay, which is our malicious DLL, okay. And then this is my IP address, as you can see, which is again like the one which I mentioned in the code snippet too, okay. Then I'm hosting the file, okay, from as you know, this is my attacker machine, so I'm just hosting it here. And similarly, I'm just going to open a new tab, and here I'm going to start a listener, right? So the core idea over this attack is like as it is reflected, it will directly download it and load it into the the address space of the target process, right? And directly we'll be able to get a shell. Okay. So yeah, if you just go to this. So I have my reflective DLL injection.exe here, okay. And if I just run this, okay, and if I just go back to my attacker machine, as you can see, I got a shell here, okay. So that's what the core part over here is. I guess this time even the Windows Defender was kind of on, and literally I bypass it as by loading the entire DLL into the memory, right, instead of writing it onto the disk, right. So that's the part here. So again, like while talking about the prevention for reflective DLL injection, it's about like you can smell for some abnormal memory allocations, right, and also some memory regions. Of course, they are crucial, right, and you can also detect any sort of manual mapping behavior, any sort of manual mapping being taken into account, right. Then of course we can focus on behavioral based detection, of course. Then I would still say that advanced, not kind of advanced, some even a mediocre EDR can easily detect reflective DLL injections too, because this part, I mean, it's fine, but the code which I used here, it's like a very basic code. I have like I didn't really implemented any sort of additional obfuscation stuffs and all. Okay, I didn't implemented those. Okay. But if possible, we can implement that and we can bypass areas if possible. That's another part. Okay. So with that, we are actually to the end of the session.